Here is another example involving population. So the population of a small town increases by 2% per year. If the population at the start of 1980 was that, what is the predicted population at the end of 2020? At the start of 2020. So the first thing that we need to establish here is the formula to use. Now, the best approach to do this is we want to find the population after several years. So, assume we want to find the population after n plus 1 years. That will be equal to U1 R, and then you plug n plus 1 in place of n, because this is the formula for nth term. So n plus 1 minus 1, which will be equal to U1 R. Now, if you simplify that, that will be just UN. So basically what I'm trying to say here is the population after n plus 1 years will be U1 R to the power n. So, once you establish that, which is very important, that is the population after n years. We need to identify how many years you're working with here. We know that our first term is, now our first term is 12,500. We know that the population of the town increases by 2% per year. So R will be 1 plus 2%, which is 0.02, which gives us 1.02. Remember, this is an increase for us from a certain figure, which was the original population 1980. So that's why we have 1 here. It's same as 100% plus 2% every year. Okay, so that's why you have to have that. Okay, so we have U1, we have R. Now we need what N is. Now this is from 1980 to 2020. So 220. That's almost 40 years. So 40 years. N is equals to 40. Which means the population after 40 years will be U1, which is 12,500 into 1.02 to power 40. I'm just using this formula here, okay? This formula that I've already established. And that will give me 27,600. That's it. Here is another example. George deposits that 2,500 in an account which pays interest at 6%. So 6% per annum. Let's just say that's per annum. It's the same thing. That's the amount deposited. So that's our P. Okay, assuming he makes no additional withdrawals or deposits, how much money will be there after 8 years? So our T is A. Now for A, interest is compounded yearly, so N is equals to 1. So our formula for compound interest will just be simplified. It will be A is equals to P into 1 plus R to the power N, to power T, sorry, not N, to power T, because N is equals to 1. So this will be equal to 2,500 into 1.06 to power 8, which will equal to 3984.62. And then for B, compounded quarterly, so n is equals to 4, which means our formula will be amount is equal to 2,500 into 1 plus 6 over 4 multiplied by 4 times 8, because t is 8. This, you can simplify this equation to 2,500 into 1.015, because 6 divided by 4 is 0.015 plus 1, you get that, to power 32, which gives us 4025.81. And then for C, we'll have the amount is equal to, now let's look at that compounded monthly. That will mean that n is equals to 12. So formula will be 2,500 into 1 plus 6 over 12 to power 12 multiplied by 8. You can just plug that in your calculator, which will give you 4035.36. That's it. Here's another question. In a geometric sequence, the first term is 6 and the common ratio is 1.5. And in an arithmetic sequence, the first term is 75 and the common difference is 100. Good. After how many terms will the sum of the terms in the geometric sequence be greater than the sum of the terms in arithmetic sequence? So let's start with the geometric sequence. For the geometric sequence, the first term is 6, the common ratio is 1.5, which means that the sum of n terms, because this is a finite geometric series, will be equal to u1 into bracket rn minus 1 over r minus 1, which will be 6 into 1.5 to power n minus 1 over 1.5 minus 1. For the, and this one can be simplified as 6 into bracket 1.5 to power n minus 1 over 0.5, which can be simplified as 12 into bracket 1.5 to power n minus 1. I'm just simplifying because I can simplify, but it's not necessary in the exam to simplify that, unless you're asked to. Now, for the arithmetic series or arithmetic progression, so what we have is u1 is 75, b is 100, which means that the sum of n terms will be n over 2, this is the formula, 2u1 plus n minus 1 d. Substitute those parameters that we have, so we'll end up with n over 2 multiplied by 75 plus n minus 1 multiplied by 100. This can be simplified as n over 2 into bracket 150 plus 100 and minus 100, which is n over 2 into bracket 100 n plus 50. So we have these two formulas. The question is, we need to find n. So they want us to find n when after how many terms will the sum of the geometric series, and we know that the sum for the geometric series is 12 into bracket 1.5 n minus 1. When will this sum be greater than the sum for the arithmetic series? No need for those brackets. Okay, we're going to use our calculators. You go to second table. Just by inspection, scroll down and see where y1 is greater than y2. And you can see that that is after when n is equals to 18. So our solution will be when n is equals to 18.